to the cloud. I have started recording the cloud. I have started recording the class, and in last week we solved almost 40 data analysis and data mining problem. Okay, so today we are going to finish rest of the problems. Okay, do you have any questions or comments? Yes.
Yes. So for the homework 2, on the document, it is due on the 6th of February, but on Western Online, it is 4th, 2 days before.
Okay, in the homework it is written 6,
Yeah.
and in the Western Online 4. Okay, okay, I will change it. Yeah, I will change it. So let me first run the packages. These are the packages. Okay, let me first run these packages again. The packages is being run, and now let me run the directory. So my directory is this one, but my data was in download folder. Okay, so if I go there, take a download folder and class practice data. This is the class practice data. So properties, and this is my working directory, because in that working directory my data is staying. Okay, so now change the working directory like this, come in here, and then I just put it in there and go change it to os dot change directory. Then I put here this, change it to /, and then I just want to put it in there, this and that. So that is my working directory. Okay, so I run it, my working directory is working. So in last class I stopped up until problem number 40, I guess. Let me check the problem. This is the document. I stopped maybe at 39 or 40, something like this. Okay, so let me run all of this up until 38, because we already solved this problem. Then I will go slowly for the rest of the problems. So there are altogether 84 problems. Let me start doing these things. This is my data. Data has been run. Runs perfect. So let me start from 38 then. And you are also seeing my videos that I put in the YouTube, right?
Yes.
YouTube, right? You are aware of that, right? I'm not putting it in the Western Online because they take a lot of memories of them. So that's the reason. But previously I also put them. But if you have a problem with that, I can also put these things in the Western Online as well. Okay, Let us check the question number 38. Create a new D3 data from D2 data by selecting only unique records, which we did it in here. What? Unique record. Which I already did. Okay, I think it should come to here. The class practice one. Let me check D3 dot NP dot shape and D3. Yeah, 1440. Okay. This 1440 is the people who are unique. So there is not a person who is appearing more than once in here. Okay. So question number 38 is telling you from the original data, which is from D1 and we came down to D2. D2 is the data where we deleted all missing values in here. D2 is this data, and this D2 data previously from the D2 data, all missing values are deleted, and now we come down to the data D3. In this D3 data, there is no repeated measurement. Okay, there is no repeated measurement. Each person is appearing only one time. I ask you to please read this Word document 2-3 times. Understand? Read this document 2-3 times, because once you start a job in a company, main task, 80% or 90% of your time will be gone for data analysis, data cleaning, data editing, variable recording, creating graphs and charts, and finally after that, remaining 15 to 20% or 10% of the time for the predictive modeling. All the data that are coming has a lot of mess inside the data. Okay, so please read these documents thoroughly again and again, so you will easily understand how to create a new variable, how to delete something, how to add something, how to find the summary statistics, how to make the graphical representations, how to find the bivariate frequency table, all of these things. Okay, so now question number 38 is the creation of a D3 data which has only unique ID. So that means a person should have only one measurement. Then from there, we want to go to the question number 39. Question number 39 is asking you, draw pie chart for the raise variable of the D3 data. Raise variable of the D3 data. So come in here. I took the draw pie chart for the raise variable. D3 data. Here I am doing it for the smoke variable. Here I am doing it for the smoke variable. And if you take a look at this, this is the smoker versus non-smoker pie chart. Okay. So take a look. Sometimes graphs gives you all the information almost immediately, right? So someone take a look at this graph, what decisions he will reach. He will reach that, well, in this pie chart, we see the number of smoker is way smaller compared to the number of non-smoker people. Okay, this is what someone immediately guessed.
Okay.
Yes.
So isn't it optional to do the exclude code in terms of pie charts?
Okay, so if you do not want to do the explode, so you just comment it out. I just want to comment it out. then explosion is gone. Okay, so now if you do these things, that will be the chart. Okay, either one is fine. In your homework, if you explode, use explode. If you use no explosion, that is fine. And then I want to do the smoker and non-smoker bar chart. So this is the bar chart. Okay, this is the bar chart. Question number 40. Question number 41. Draw a bar chart, pie chart for the income variable. Now, income variable, if I go there, I have to spend some time in here. This is the income variable. Now take a look at that. First, line number 236, I wrote PD, that means panda cross tab. That means frequency I want to find. Cross tabulation means frequency. Index equal to D3 is the data sets. From there, I am taking the income and finding the frequency by column. Columns, that means. So if you just run these things, take a look what I am getting. If I just run the line number 236 and then see what I am getting in Python, it is just the column and count. Income is the level. So that is why I put there columns has a title, column has a heading, which is count. Okay. So why I find this? Because these informations I am going to use in there. These 80, 69, 57, I'm going to use in here. Okay. From line 36, the output that I got, I am putting that output in the line 2040. And then I want to put a color, and then color is like black, brown, blue, yellow, red, gold, pink, purple, olive. Okay, these are the colors. And if you do not like this color, link for the list of colors name, you will find it in there. Okay. If you suppose instead of now there is 9 categories, suppose you want to do 20 categories. Okay. 20 categories of the American people, if you want to do, you can easily do the 20 categories, right? So in such a cases, 20 different colors, you can put like that way. There is also, you can say that how about 30 colors? Should we put all of these 30 together like this? No, there is a way to write this in the looping. In the loop, you will write and then put, when I equal to 1, they will take this color, I equal to 2, they will take that color, I equal to 3, they will take that color. Looping, I am coming very soon. How to work with the multiple data sets together. And then port size, you have seen the figure. The figure looks like this. Okay. So from this figure, you can see that extremely rich people and very poor people almost have the same percentage, right? Very poor people may be bottom 2%, bottom 3%. Extremely rich persons may be bottom like the top 3%, top 2%. Okay, this is. By the way, this is the name that you are saying very poor, poor, not poor. This is what I made from the 7 and 9 different levels. Okay.
Yes.
Question?
Not poor and poor. It's very equal to all poor and very poor.
So it is very poor
and poor.
Poor, not poor, and the middle, upper middle, rich, very rich, super rich, extremely rich. So not poor means they are not in this category. Or we can put here lower middle.
Yes. So,
okay. You like lower middle? Lower middle makes more sense, right? Is this what you want?
No, my question is that in case of the pie chart, we have to bring the percentage for each of the fraction. Especially it's difficult to.
That could be done also. So he is asking, instead of this, can we put their percentage? That could also be done. How about if I assign that thing as a homework? Why not? That's the way you have to learn.
Okay.
She showed up today in the class, right? With a code, right? And then for some reason it is not coming, but I checked in the online, I found it. Believe me, let me tell you one thing. Let me tell you one thing. When I came USA, I just know the SPSS. I even did not know how to type without. And then I saw some students are doing typing, American students. I asked them, how do you know all of these things? They said that there is a typing master's game. Just I played 3-4 1 week, I become a typing master. You have seen that, right? And then R, the SAS professor taught, I learned. R, I never heard. R and Python, I never heard. Python, I heard first 2015. Before that, I never heard. After finishing my PhD, after doing my PhD, then I heard about the Python. I was doing the R. Okay. So now, a person's know lot of programming, lot of knowledges. You, all of you at least use once Excel, right? Right? Now you are using also, some of you also use the R, right? And some of you now are using Python. And many other people, maybe you also use maybe MATLAB or some other things. Why this is possible nowadays? Because online. Because of online. If this is now 1980s, suppose we are in the 1980s, we should have a Excel or R or C++ book. So it is not working. So let's go to the index, let's go to the dictionary, okay, do a come like this way. Understand? So she came today for a coding. So I have to spend 2-3 minutes to find the code. And finally I find and I gave it to. So as you are saying, this is not the way I better want to put the percentage. I can put the percentage in there. So just write Python code to percentage in the pie chart. Just write these things. Python code to draw pie chart with percentage. You will get the Python code. Clear? Did you understand his question? His question is, I want here percentage. That could be done. In next semester when I will teach, I will add that one as well. Okay. So this is the way all of these things, the colors you can find in here, okay? All of these colors you can find in here. Okay. Now I want to find the bar chart for income variable. This is the bar chart for the income variable. Okay. This is the bar chart for the income variable. Clear, right? This is the bar chart for income variable. Don't mess up bar chart with the histogram, okay? Don't mess up bar chart with the histogram. Histogram is for the continuous or quantitative variable which we are coming, but bar chart is for categorical or qualitative variable. Okay. Now I want to put bar chart and pie chart together. Okay, title. That's the good thing that you are trying to fix me. Income variable, okay? Awesome. Okay, happy now? Oh, okay. Okay. How can you fix that, right? So he has like, so there is a code. If you put like slash in there, then it will be fixed. Okay. Did you get his question? So poor, very poor, and there is overlapping, something like this. So how can you fix this? There is a way to fix this. So instead of one line, it will be line broken to 2. Okay. Now come to the question number 3. two graphs I want to get in one grid. 2 by 2 grid, 3 by 3 grid, 4 by 4 grid. Okay. This is the pie chart for raise variable, actually smoke variable, and the bar chart for the smoke variable. Okay. Let me change it to smoke. And let me change it to smoke. Now, 2 by 2 plot of race and smoke variable. Race has two category, African American and Caucasians, and smoke has two category, smoker and non-smoker. So 2 by 2 plot means 2 row and 2 column. So that is what we are going to discuss now. So are you seeing 221 on the line number 281? That means 2 row, 2 column, figure 1. And then line number 291, 2 row, 2 column, second figure. Okay. Then 2, 2, 3, 2 row, 2 column, third figure, line number 300. And line number 310, 2 row, 2 column, fourth figure. Okay. This is the four figure. Smoker, non-smoker, non-smoker, smoker. This is African American, Caucasians, African American and Caucasians. Okay. Now question 45, there is a two types of bar chart between two categories. Suppose I want to put race as well as income in one chart. Understand? Race and income one chart I want to put. That is known as the stake bar chart. And then I want to put race and income side by side, and that will be called the group bar chart. Okay. So first one is stake bar chart. I want to construct these things. I'll go over the code, but first of all, let me put it in this format. This is called the stake bar chart. Okay. So income level 1, I put the purple one is African American, and then red one is Caucasian. Okay. So this is, that means two income group and their frequency. If there is altogether 100 in here, altogether 100, that could be like, if it will be maybe 10, then that is 90. Understand? That is called the stake bar chart. So you can immediately make a decision. Well, for the income level 5, African American and Caucasians have the same share or same percentage, right? By this figure, you can say. On the other hand, for the income level 9, you can say that African American has a higher share compared to the Caucasian. In the income level 1, American has more share, more percentage, more frequency compared to the African American. You understand? So that is the way stake bar chart is important. Now I want to see the group bar chart, side by side bar chart. So let me see if there is anything to explain. So first one is finding the frequency. the line 322, if you run, that will give like cross frequency of the two category. If you run this one and then come in here, this is called the group frequency. Raise 1, raise 2, income level 1, raise 1 has 70%, income level 1, raise 2 has a 10%. These informations I am putting on the line 326 and 327. Okay? 326 and 327 I am putting in here. You might see that, well, this number is differing. The rationale is that when I write this code, I subsetted the data in different way. So that is why frequency is different. Are you understanding? You might ask me question, hey, professor, 70 and 10, where is 70 and 10 in here? You understand?
So that's the frequency.
This is the frequency actually. Raise 1, you will put these things like 10, 15, 9, are you seeing 14, 18, 13, 80, something like this, you will put there and that there. Now the question is why this frequency is different? Because when previously when I subsetted the data, I subsetted the data with different characteristics. That is why frequency is different. When I wrote the code, originally when I was writing the code, I was subsetted the data with different characteristics. So that is why my percentage is different from this percentage. Understand now? So if you don't believe me, just copy these things, put it in line 327, copy these things, put it in the line 326. Clear?
Yes.
Happy? Yes.
Yeah, I want to know the different circumstances where the numbers you bring array names, you list the numbers, and a situation where you don't have to bring the array like this.
You want to write this number instead of this format in the array format? Is this the question?
Yeah, I want to know differences when we have to do that and when we don't have to do that.
Oh, okay. That is a good question. Okay, I will answer your question. Okay, that is actually good question. So he is asking whether the line 326 and 327, I am declaring the numbers in here. What is the difference? Suppose this line 326 and 327, I want to declare in the format of an array, and then when I should use the array, when I should not use the array, right? Can anyone in this classroom answer this question? Okay. Because when he did the homework one, some of the number he has to declare in the format of an array, right? And when you put the array, you put the double square bracket, right? If I remember correctly. And I think if you put the format in the array, the matrix this is my immediate answer based on assumption. If you do everything in the matrix multiplication or anything, I think that should be put in the format of an array. Understand? But on the statistical computations and other things, this is the way you have to put this. I will check more and come back to you, okay? Maybe by tonight, if I remember. I promise I will not go to bed. I will not close my eyes before finding the actual answer. But array things are usually used for matrix multiplication. In that way, if you put the information in this format and try to multiply, I hope it will not I hope, I guess it will not work. Okay. This is explanation. So you saw that one. Now I want to see the group bar chart. From next class, I will come with just a t-shirt in the classroom. I am boiling inside. Okay? The room is very hot.
Yes.
Okay. Okay, now let me run this. And this is the group bar chart. Okay. So group bar chart means, are you seeing this is the income level 1, this is the African American, and that is the Caucasian. Okay, income level. You are getting it, right? Okay. Now I want to put stack bar chart and group bar chart together. I have to run this line of code. What I have done, I just copy the previous lines of code and put it in there. Okay. Okay. So far the graphs that you have seen, we constructed graph for the qualitative variable or categorical variable. Okay. Qualitative variable or categorical variable. Now, if we have the quantitative variable, or more specifically, if I want to speak, if our variable is continuous variable, what type of graphical representations or visual representations we can obtain from the data? Okay, so first one is called the dot plot. Dot plot means what? Observation. So for example, if you take a line number 395, where I am taking DBP from the D3 data, line 395, I am taking diastolic blood pressure from the D3 data. So this is the data, and after taking the data, here I put the observations number in here, and then here I am plugging all the values in there. Okay, DBP values. So in this case, these are the values of the DBP, and this is actually put in the observation number. So that is why, are you seeing 0, 5,000, 10,000, 15,000, 20,000? Are you seeing that? So values are plotted, values are projected by the number. So I have a diastolic blood pressure for the suppose 20,000 people, right? 20,000 people diastolic blood pressure number. So it has been one first person and his plot, second person his plot, third person his plot. It has been plotted by the observation number. Okay, observation number, it has been plot. Dot plot is a plot that is construction by observation number, by the position of the observations. Okay, now I want to do the dot plot for the race 1 and race 2. Take a look at the line 402 and 403, where I denoted x1 as a DBP value for the race 1 and x2 as a DBP value for race 2. X1 is the DBP value of race 1, x2 as the DBP value for the race 2. So now I want to do 2 by 1 plot. That means 2 row and 1 column plot I want to do. So that is why I write on the line number 404, 2, 1, 1. 2 row, 1 column, 1 figure. And then line number 408, I wrote 2 row, 1 column and 2 figure. So this is the 2 figure. Okay, this is the 2 figure. Now I want to construct the histogram. This is the SBP I have taken from the D3 data and want to construct the histogram of the SBP for the entire data. This is the histogram. Okay, this is the histogram. Now let me open this document. Are you familiar with this? Normal distribution? Are you familiar with this?
All right. Right.
Okay, good. Now the question is, how do we obtain this card? How do we obtain this card?
The last way. How do we obtain this?
Yeah, so this curve, how do we obtain? Do you understand? So you say this is a normal distribution curve or symmetric curve. This is skewed to the right curve or positively skewed. This is skewed to the left or negatively skewed curve. So how do you obtain this curve? Do you understand the question? Okay, you raise the hand.
Yes, where the positively skewed one is where probably an outlier that has a higher value to the normal distribution to the right.
Okay. I am asking, how can I construct this curve? He is telling that in this case, outlier will be in the right. In this case, there could be outlier in the left. But my question is, how do you construct this curve? What is the other name of this curve? You say normal curve or symmetric curve or bell-shaped curve or mound-shaped curve. This is known as the normal curve or symmetric curve or bell-shaped or mound-shaped. Shaped curve. This is called the positively skewed or skewed to the right. This is called negatively skewed. Or skewed to the left. Okay? Positively skewed or skewed to the right, negatively skewed or skewed to the left. My question is, how can we construct this curve? How? I have given you some continuous data. From the continuous data, how can you construct this curve? Do you understand? I give you some data like income of 100 students in each month at WIU. How can you construct this? What? Line plot? How can you do the line plot? Take a look. How this curve is constructed. This curve is coming from histogram. Okay, never forget these things. Take a look at that. What we do, how do we construct the histogram? Suppose this is the income. Right? An income class interval and income frequency. Okay, people has income 0 to 20K, 20 to 40K, 40 to 60K, 60 to 80K, 80 to 100K, and then 100K plus. Understand? Right? Suppose there is, I have altogether, suppose total equal to suppose 500 people. Okay? Suppose 500, 0 to 20K, suppose I have 50 people. Here, suppose I have 80 people. Here, suppose I have 100 people. So here, suppose I have 150 people. And then here, suppose I have 150, 300, 300. So this is 20, 400. Suppose this is equal to 100. Do you understand? Clear, right? That sum up to 500, right? 200, 300, 200, 300, 400, 500. Take a look at that. I am writing this. So 0 to 20, 40, 60, 80, 100, and plus 100K, right? Bigger than that. So something like this. So now I want to construct. This is my frequency. 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 So suppose this is equal to 50. I got in here. And then next one equal to 80. This is equal to 50. This is equal to 100. Then this is equal to 75. This is equal to that. And then there is 101. Then 150. Then again 100. Then again 20. Right? So what we will do, we will add this top middle point of each bar by a smooth curve. We get a curve, right? We get a curve, right?
Yeah.
Understand?
Yes.
So now take a look at that. This is cut off, right? This is cut off from this curve, right?
Yeah.
But that is included. That was not part, right? That was cut off. That was is included. That was cut off. That was included, right? This is cut off. That is cut off. But this and that things are included, right?
Yeah.
So that is the way you get the frequency curve. So this curve is coming from frequency, right? That is why it is called the frequency curve as well. Clear? This is called also frequency curve because it is constructed from histogram frequency by adding the top middle point of each bar. By adding the top middle point of the each bar. So if you, after constructing this curve, if you find this, your curve is symmetric. In this case, mean equal to median equal to mode, then it is you call this curve as a symmetric curve, normal curve, bell-shaped curve, or mound-shaped curve. Okay? You understand? But keep in your head frequency curve or this curve, it is coming from histogram. Okay? Continuous data is in there. From the continuous data, I can make a class interval. Corresponding to class interval, I get the frequency. I add the top middle point of each bar, the curve that we obtain. This is called the frequency curve. So there are three frequency curve. One is called the symmetric curve, bell-shaped curve, mound-shaped curve, or normal curve. Second one is skewed to the right. Third one is called the skewed to the left. Okay. So now when I will get skewed to the right curve, so in this case, highest peak, right? So that is the highest frequency, right? In this case, it is called the mode. Okay? MOD mode. Median is always in the middle. Remember this. Whoever come to you, want to argue with you, always say median is in the middle. Okay? And then mean is in the right. For example, the Macomb city people have average income of maybe 60,000 or 70,000, right? Macomb is a small city, 60,000 or 70,000. But accidentally, like our President Donald Trump is included in the sample. Then what will happen? The mean will increase, right? Understand?
Yes.
So 1 or 2 rich people, if included in the sample, they will drag the mean to the right. So that is why mean is in there. Okay. On the other hand, in this case, this is the highest peak, this is the mode. Median is always in the middle. Median can never be in the extreme side. And mean is in here. Mean is in here. What's the realistic example for this case? Beverly Hill is a rich place in USA where celebrity lives, right?
Yes.
And their yearly income millions of dollars. And poor taxi driver or plumber, they go and fix something, their income is 80,000, 90,000, right? If 3-4 plumber is added in their data in the samples, then mean will go down, right? Understand? So this is the case, you will get this type of distribution. Okay? I always give this example so that my students will never forget these things. Clear, right?
Yes.
So what you learn, how histogram is constructed, and sorry, what you have learned, the frequency curve is actually coming from the histogram. Very important thing. So this is called the frequency curve as well. So you understand, right? How this is histogram. If you add these things, then you will get a frequency curve. Okay. The idea of histogram first showed up in around 17th century. Okay, 17th century. How can I represent? See, for example, if you have a 200, 300 continuous data, how can you visualize? Think about yourself that you are now in the 16th century. Okay. So coming up with new idea, they versus, well, this is the data. Let us put these things. Let us move a class interval and find the frequency, and for each class interval, put a bar and then add the top middle point. Okay.
So it's we did take inspiration from Abacus.
That is what I am not sure. You are talking about whether they took the idea from Abacus, right? But if you search in the Wikipedia, I forgot the name, who first proposed these things in Europe. First, it was proposed in the Europe. Okay. Okay. Now, I want to do 2 histogram for the African American and Caucasian for 2 races. This is the 2 histogram. Okay. This is the 2 histogram for the African American and Caucasians. Now I want to find the box plot. Okay. Let me do the box plot and run the box plot and then give you the explanation. Have you seen this box plot before? Can anyone tell me how the box plot are constructed? Quartile. So that means this is a first quartile, this is second quartile, this is third quartile, right?
Yes.
That is, everyone understand. How do you draw the whisker? Can anyone of you tell me? Minimum or maximum of the data? Not minimum and maximum of the data. Okay? Let me give you the explanation so that you will never forget. Thank you. So how box plot is constructed, now let me give you the explanation. So suppose I want to draw some data 20, 19, 17, 15, 7, 30, 41 to 10, 5, 19, 20, 16, 25, 24, and then 10, 11, 15, 16, 15, 10, 12, 14, 15, something like that. How can I construct box plot by paper and pencil approach? And most importantly, how to construct the whisker. That is the most important part. Many people messed up with the maximum and minimum value. That's few of you said already. So in this case, what is the minimum value? Minimum value is 2, right? 2. And then what is the next minimum? 5, right? 5. And then after 5, there is a 7. Then there is a no 9, nothing.
Sorry, I see 2 tabs.
10. 1, 2, 3. 1, 2, 3. After 10, then 11, 12, 14, 1, 2, 3, 4, 15. After 15, then
16.
1, 16, 2, 16, 17, then 19, right? Or 18? 1, 20, 24, 25, 41, right?
Yes.
So minimum equal to 2, maximum equal to 41, right? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13, right? So my median equal to 15, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the median. Average of 15 and 15 equal to median. Okay. So now this is the first half. From there, I want to find 1, 2, 3, 4, 5. So that is the middle 2. So median equal to 10.5, right?
Yes.
So this is the second half. This is the second half. So 1, 2, 3, 4, 5. So 19.5, right? So this one is my Q1, Q2, Q3, right?
Yes.
So now you have to prepare a box. That box should go by the scale. Whatever I should put in here, and then from there I have to go by the scale, exact scale. So this is suppose 10.5, right?
Yeah.
So 10.5. So and then 20, if it is 20, 10.5, then 20.5, it is in there. Suppose this is 19.5, okay? 19.5, Q1 and Q3. So my 15 will be here. So 15 will be closer to that one, right? Closer to 19.5, like 10.5, 11.5, 12.5, 13.5, 14.5, 15.5, 5 unit. So 4.5. And that one is 15, 16, 17, 18, 19. So exactly same, right? Exactly same. So that means it should be exactly in the middle. Are you understanding?
Yes, sir.
So the distance is 4.5 according to our data. Now see, you have to find lower inner fence. Lower inner fence what? Q1 minus 1.5 IQR. IQR means what? Interquartile length. IQR means Q3 minus Q1. Okay. So what is my Q3? 19.5 minus 10.5. So we have 9, right? So then we have to put here 10.5 minus 1.5 times 9. So what would be the results in here? 14.5 minus 10. So that means negative 4.5. Do you agree? Ten 10.5 minus 1.5 times 9.
That's fine.
10.5 minus 1.5 times 9 equal to 3. Is this 3? 3, right? Negative 3. I need to go to the elementary school again. Clear, right? This is the lower inner fence, right? So you have to come all the way by scale. You cannot randomly do these things by scale. So suppose this is the lower inner fence. Okay, this is the lower inner fence by scale, which is equal to negative 3. Okay, now let us call the upper inner fence. Let me do these things in here. Home, draw. Okay, draw. Let us consider upper inner fence. Upper inner fence equal to Q3 plus 1.5 times IQR, which is equal to 19.5 plus 1.5 times 9. So 1.5 times 9. So then what we are getting in here? 19.5 plus 1.5 times 9, 33, right? So 33, suppose it is coming 19.33 is coming in here. So this is called the upper inner fence. Okay. Now you need to pay attention. Okay. So I computed lower inner fence and upper inner fence, right? Draw the whisker to the maximum of the data within the upper inner fence. What is the maximum of the data? 30. So that one equal to 33, right? That one equal to 33, right? That one equal to 33. Draw the whisker to the maximum of the data within the upper inner fence. Within the upper inner fence, maximum equal to 30. So we have to stop in here. Listen, draw the whisker to the maximum of the data within the upper inner fence. Within the upper inner fence. Now, 41 puts in there, right? 41 is in there. It is outside the upper inner fence, right? That is called the outlier. Draw the whisker to the minimum of the data. What is the minimum of the data? 2. So I should stay in here. Suppose in this data I have negative 14. Are you understanding? Suppose in the data I have negative 14. Can I draw this to the negative 14? So let me write it in here. Write it down. Draw the whisker. Draw the whisker to to the minimum or maximum of the data, draw that to the minimum and maximum, not or, and minimum and maximum of the data within lower inner fence and upper inner fence. Sorry for my ugly handwriting. Usually my handwriting is not that bad, but when I start writing very fast, you understand, right? So do not draw the whisker to the maximum of your data. Listen, draw the whisker to the maximum of the data within the upper inner fence. Draw the whisker to the minimum of the data within the lower inner fence. This box plot was discovered by 2K, famous statistician in Ohio State University in 1970. Okay, is a very famous statistician. He had a lot of theorem he proposed, and in 1975 he also said that regressions that we are doing, it is looking for the average of the data. We should go outside of that and want to find the predictive modeling, which can also describe the like extreme other percentiles of the data. So based on his comments, 3 years later, 2 years later, quantile regression was developed. Okay. So I spent some time in here to explain you how box plot are constructed. I hope you will never forget these things.
Yes, sir.
This is the box plot for the SBP values. So now I want to do 3 by 3 plot. That means 3 row and 3 column. If there is 3 row and 3 column, then how many? There are 3 row, 3 column, then how many figures there are altogether? Can I take the phone? This is from Macom, I don't know who. Hello? Oh, okay. So can we talk tomorrow, because I'm now teaching a class? Okay. So 3 row, 1 row, 2 row, 3 row, and 1 column, 2 column, 3 column, 3 by 3, 9 figures I want to construct. Down the road, in order to see all types of differences, you might need to construct 5 by 5 figure. That means 25 figure. Okay. So this is the way 3 by 3 figure for the dot plot, histogram, and box plot together. You can find all of these things in there. Line number 486. Line number 486, are you seeing? 339, 3 row, 3 column, 9 figure. Line number 483, 3 row, 3 column, 8 figure. Understand? 8 figure. So if I run these things, you will see fantastic 9 figure. There is the 9 figure. So this is DBP for entire data, histogram for the entire data, box plot for the entire SBP. This is the SBP for African American, SBP for Caucasian. Box plot for African American, box plot for Caucasians. Okay, this is the way 9 by 9 figure you can obtain. Okay, yes.
Regarding the box plot, so sometimes I get confused how to determine the skewness if it's plotted vertically.
Okay, he is asking how can we determine the skewness, right? So let me answer this question by writing this. Suppose this box plot median is in here, okay? Move. This box plot, median is in here, right? Suppose median is in there. So this part is longer compared to that part, right? So that means it's skewed to the right. So suppose this median is in here, this part is longer than that one, skewed to the left or negatively skewed. If median is in the middle, 50-50, then it is symmetric or normal or bell shaped or mound shaped. Okay?
But what if it's plotted vertically?
Oh, either way is fine. It is horizontally you can put, if horizontally you can put, this is your quartile, first quartile. If you put it vertically, bottom one will be your first quartile. Okay? So that's the way. People usually do not count from top to bottom, right? So people go to top to bottom or left to right, people cut it. Go. Even in the Arabic and then Hebrew language, who reads from right to left. Arabic from right to left and Hebrew from right to left. These are two Oriental languages, right? But their number is again left to right. You understand?
Yeah.
I don't know any other language exists who read from right to left. How do you know? Arabic. Oh, okay. But Arabic number is from left to right, right?
Yes.
Left to right.
Letters are marked.
Yeah, letter from like writing, Arabic writing from right to left, but Arabic number is from again left to right. Okay, okay, okay. Yes.
So is it possible to run a code that will have one demarcations like a frequency and another variable instead of each clause having its own demarcations, like it has become plain instead of making it one demarcations for all the clause.
Could you tell me the question in
So
different ways so that I can understand?
yeah, so here we have 9 different plots.
Yeah.
And each of them has their own demarcations, like the
Yeah, each figure has its own, yeah.
yeah. So I'm asking that is there a code that will put everything together with only one demarcation for all of them?
So what I have noticed, this is actually a good question. Suppose down the road, we have to do, listen, down the road in scientific paper, when you will write, you might need to compare 25 things together. So 25 figures. I have seen a paper that has 25, 36 figures even in scientific research paper. In such a cases, they just put a level 1, 2, 3, 4 up to 25, right? And the bottom, they give a big descriptions for each of these. So they write one, this is the figure for that, from there we have seen that. This is the figure from that. So one level they have written. Because putting the figure, that many figures, as well as their title, as well as the x-axis level and y-axis level, is not possible, right? So that is the way I have seen one scientific paper at least that had lot of things. Okay. You can have a 5 minutes, 7 minutes break. Then I will start. So I am pausing it. Please give me a reminder so that I can record. Okay, once you'll come. So we will start again maybe 7:20. 7:20. I'm recording. I started recording the class. And let me go there now. Now, there is some kind of plots. That plot has a name. I want to see the, if you take a look at the line number 495, I am picking 4 variable SBP, DBP, TC and TZ. When there will be plot for SBP and DBP, that will be a scatter plot. So that means SBP is in the x-axis, DBP is in the y-axis. Okay. And then when it is in the same axis, then it will be just a histogram. Let me run it and then show you. What happened? Okay. So I did not run that code, that SNS. Okay. So I have to import that code. So let me import that one from there maybe. There is a package that I need to run. 50. Okay, so go to the top. That one, the line number 7, okay? Line number 7 is telling you C1. So I need to import this package which I imported in here. Now if I go to the line number, question number 55. Now take a look. So what does this mean? I have to explain these things. Take a look, line number 495. I am picking 4 variables, SBP, DBP, TC, total cholesterol, and TZ triglyceride. So this is the figure SBP with the SBP. Within the same variable histogram, and this is the SBP with DBP. So as SBP is increasing, DBP is increasing. So that is why that is an increasing trend. Are you seeing? It is going up, right? If you have some figure, from the figure you have to give some explanation, right? So this is the figure between SBP and DBP. This is the figure between SBP and TC. This is the figure between SBP and TZ, triglyceride. This is the figure between DBP and SBP, DBP and DBP, DBP and TC, DBP and TZ. Okay. So that is the way you can find scatter plot as well as within plot. Within plot means this is the same variable. This is for the SBP. This is for the DBP histogram. This is for the total cholesterol histogram. This is for the triglyceride histogram. Rest of these are scatter plot, pairwise scatter plot. Clear, right? So more of these things can be obtained. If I want to see lot of box plot for between a quantitative and a qualitative variable, then that could be done by using this. In this case, are you saying I am putting X as an income, X as an income? From the D3 data, I consider X equal to income. This is the income. And corresponding to each income level, I want to find the box plot of the SBP, Y equal to SBP. Clear, right? So question number 57 is telling you how to draw a sample from a data frame. So in this case, I am drawing from the D3. Take a look at that one. Python D3 is my data, that NP dot shape. And then I want to take a look at the how many data is in there, 14.40. So 14.14 row, sorry, 1440 rows, I want to pick 200 rows. Okay. I want to randomly pick 200 rows. And the question number 57, if I run this line 507 up until 511, then I see this is the data known as the random subset. if you take a look at the NP dot shape, and then if you write here random dot underscore subset, then you will get these things, 200 rows and 28 columns. So what you learn from the question number 57, suppose you started a job in a company and you are first day you are given a data that has 1 million rows. Okay, and then the guy told you, okay, this is the data that is 1 million rows, and report me at the end of the day about the data and what do you think about this data and what are the important variables. What he will do, he just give you the data, right? And then you will run the data, you will find the dimension of the data, how many variables, how many rows, and then you say how many of them are categorical, how many of them are continuous, and then as you know what company is doing, you find some variables from there, and then after finding those variables, you can report that these are the variables I have found. In addition to that, from 1 million rows, I take a 1000 sample, I do the histogram box plot. This is what looks like. Now next time I'm going to do these things for next couple of weeks. Okay, that's the way the manager will test you. So how can you take a sample? The line number 507 to 511. Clear, right? Now you want to take a sample from a variable instead of a data frame. Previously, I took a sample from data frame. Data frame has 1440 rows. From there, I randomly pick 200 rows. Now I want to randomly pick 100 values of a variable which is SVP, which could be done by using this. Okay. So the question number 58 is telling you how to take a random sample from a variable. Okay. Okay. So now there could be a problem. How can we solve this problem? Let me see whether it will work or not. It is working. Okay. As it is working, I already took the sample. So I think this will also work. Yes, this is also working. Here is the plot. This is the stem leaf plot. Stem leaf plot means what? If your number, decimal number, so the integer part is taken as a stem and the decimal part is taken as a leaf, and then they plot these things and ultimately they got some kind of graph, and then over the graph they draw a smooth line, and if it is symmetric then they said the variable is symmetric. If it is skewed to the right, they said it is skewed to the right or skewed to the left. It is similar to the histogram. But the idea is stem leaf. If there is a decimal number, stem is considered as an integer part and decimal part would be considered as a leaf. Okay. So now in your case, if these things does not run, what you will have to do, I'm going to show you. Okay. It is not running in your case.
I have a question.
Okay. Go ahead.
Going back to the box plot with the chart with so many box plots.
Yeah. That one.
Yeah. I figured that in the chart, we didn't have to specify the colors of the box plots. But back to the pie charts, we did have to specify.
Yeah.
So I was wondering, is it because it was seaborne?
I think the guy who developed these packages, they already put like the more category box plot will come, the color will be different. Okay. That's a good thing. If someone else does the work for us, why should we care about these things, right? Okay. Have you heard the name jackfruit? Jackfruit. Haven't you heard the name jackfruit? It is not an African fruit. Jackfruit? No, it is not in Africa.
I think they grow in African countries.
No African country has this fruit. My goodness, you even haven't heard the name. This is the fruit. You never see this? You never eat it? Okay, and in entire African country there is no jackfruit.
Okay, have some.
You have in your country? Okay. In the context, this is heavy food, okay, very heavy food. If it is put in the someone else's head, then it is gone. So in the context of our society, it is said, why you are working so hard? Put the jackfruit in someone else's head and do the work from there. Okay. So someone else already developed the package. Why should we care about ourselves writing the code? Okay. Now see, you might encounter problem for this problem, okay? Are you listening? So this code might not work for you. Are you understanding? So what you will have to do, you have to go there. And then are you seeing the CMD execution prompt? So you have to click in there. And after there, you have to write here the code that I said. Pip install. This is what your stem graphic. This is what you have to write. Pip install stem graphic. Okay. So you have to go to the Python command prompt. Understand? So when you do the homework, if you start, if you watch my video, then the video will give you the answer. It is around 1 hour and 30 minutes video. If you see, you will find that. So it is now installed now. After installations, then if you go and run these two things, then it will work, okay? So the problem is you would have a problem of importing these things. If this is the scenario, go to the Python, go to the command prompt, CMD command prompt, click in there and type import pip install stem graphic, then it will be installed. And after installing these things, if you run these two, then it will work. Okay. We have 20 more problems and we have almost an hour. Let me tell you the things. You are learning programming, right? You are asked to work with the 50 data sets together at once. Understand? United States has how many states? 50 states, right? 50 states has their demographic data, average longevity, and then gender ratio, number of births per year, number of children per women, right? You have been given 50 data, or one big US data has been given. In the entire USA has a one data, understand? That has all 50 states information. And you are asked, well, you have to work with all 50 states, like vital statistics data. Vital statistics means what? Vital statistics means birth, death. That is why they call it is vital. Vital statistics, birth, death, unemployment, and then child mortality, okay? Fertility, like the number of children was born from each couple or each woman, something like this. Yearly income, longevity, okay? Disease, all of these things. How can you work with the 50 data sets together at once? This is the things we are going to learn now. Understand? How to work with the multiple data sets at once. You put I equal to 1 first data, I equal to 2 second data, I equal to 3 third data, I equal to 4 fifth data. That's the way you will run the loop, and you will work multiple data and find the average longevity, average age of death, and then number of children each woman have. All of these things you can bring at once. Okay, so now what here I am doing, here I have, these are the values, ID, TC, triglyceride, high density lipoprotein, LDL, low density lipoprotein, smoke, waste minimum, sugar, time and event. Okay, these are the variables and now this variable I want to exclude. I wrote line 533. What variable I want to keep? Variable for variable in the D1 dot columns, if variable not in the exclude. Understand? So that means from the D1 columns, keep all the variables that are not in the exclude. Okay, so that is the way default data has been created. And after default data creations, I want to check the dimension of the data, which is 20,900 rows. Now from there, I am finding the missing values like this, and then I am creating number of missing values by each row. I have created that things. Now default data, any row that has a missing values, that things will be deleted. So let me check. Now if you take a look at the data, np dot shape d5, then you see 17,025 rows. So D5 is the data. On that data, there is 17,025 rows. In these 17,025 rows, there is not a single missing entry. Understand? So there is a row number 1, row number 2 up until row number 17,025, and then 16 columns. None of these entry has a missing values. Okay, this is the complete data. Now I want to create a new variable known as the new age. Take a look at the new age I have created. If you take a look at the d5 dot head, if you take a look at the d5 dot head, so new age has been created. So how did I create? Take the age variable, round it to the 1 decimal. Are you saying it is 1 decimal, right? Previously it is 9.35. Now it is 9.4. Are you seeing? I have rounded the age variable to 1 decimal places by running the line number 554. Okay? By running the line number 554. You see that, right? Okay. Now, question number 65. I am subsetting the data further by taking new age value greater than 9 and new age value less equal to 19. So that is the line number 558. In this line number 558, I am subsetting the D5 data further by taking new age value greater than 9 and less than 19. Okay. Now, suppose I am the data manager. I know very well about the data. I have want to give this data to you. Okay. How can I give this data? So this is the data D5, the data that I have created. I want to give this data to the people who are working under my supervisions. What I should do, I just run the line number 562, which is d5.2_csv. That's the way data has been saved in my directory. There is a working directory for this, right? I declare the working directory. In that working directory, if I go, I will find the data. How can I find this? This is the way, if you check D5. Are you seeing D5 clean data? This is the D5 clean data, and I name it. This is the data. Now I can attach this data or by flash drive or in the cloud. I can upload the data. I can give I can give a 1 week time to 5 of the people and ask you independently, this is the data, this is the data dictionary, this is our company targets, so do some work and report me next week. Okay? Report me next week individually, and you should not discuss among them, among yourself, okay? The purpose, I have hired 5 people, I actually keep 2 or 3 people, and then rest of the 2 people I don't want to keep. Okay? This is a very cruel country. They just want to make money, okay? They just want to make money. And then top companies like the Microsoft, and then Facebook, Google, and all of these companies, they are laying off their people, even though they are making profit, but they want to make more and more profit. Facebook, right? They never reported that they lost, okay, but still they are, because they want to stabilize the company, they want to make sure that they will be viable, they don't want to. So the reason I'm saying that, once you will get a job, please love the job, work very hard. Unless company make losses, in that case, if they will fire you, that is fine. Company cannot make profit, they have to fire you. But company is making profit, but on the basis of your performance, you are not performing well, and they will fire you, that is very bad. Understand? And getting job in another place is also tough. Listen my advice. So you have cleaned the data and you have made the data ready. How can you do these things? D5 is the data. See, I write it here like this. This is the name of the data I write. And what I'm exporting D5 to CSV. So this is the way the code I am writing. So D5 data dot to underscore CSV. And this is the new name of the data. Okay. And it will be save to. So index equal to false means what? The row number should not be in there. Okay.
Why do we have to create a copy of the data?
Which one?
558.
558.
Like why are we creating the copy?
Oh, just I want to make a copy of these things. If you take it out, that's fine also. Okay, so now I want to split the data. Okay, take a look at that. Question number 67, I want to split the data. It has a age 9.1, right? So I want to have a data corresponding to age 9.1. So the people who came at 9.1, so suppose 50 people came at age 9.1, and then they have a different height, different weight, different blood pressure, right? Are you understanding? So corresponding to age 9.1, I have a data. So first of all, I have to split the data by group by statement of the new age variable. That is the way data has been grouped. Now see, D6 is the data that has been, that is the split of the data D5. D5 is the original data. That D5 data is split by the new age variable using group by code, and then new data is D6. Now in the D6 data, I want to take a look at the data corresponding to age 9.1. So this is the data corresponding to age 9.1, right? Are you seeing? This is the data corresponding to age 9.1. So what I did, group by 9.1. Now if I want to write another one, group by age 11, this is the another data. If I want to run another one, 15 by 5, this is the data corresponding to 15 by. This is the data corresponding to age 19. Okay. So what you have learned, you have a big data like USA data. USA data has a state variable. So if you just run the line number 566, where D6 equal to D5 dot copy dot group by, and instead of new age, if you put the state, then data will be split by the state. Are you understanding? Are you seeing I put new age on the line number 566, right? In the new age US data, if you put a state, then you will have 50 data sets corresponding to 50 states. Clear, right? Okay. So now, how many data sets in the D6? Are you seeing 100?
Yes.
Length of D6, that means it has a 100 data sets. So D6 is a list, okay? List means what? Like 30 years ago, when your grandpa go to the shopping and your grandma give a list, okay? Buy salt, buy sugar, buy flour, buy rice, buy all of these things, and he has a list and he'll go, right? So similarly, D6 is the list which is holding 100 data sets. Okay? A list has a lot of things. D6 is a list, it has a 100 data sets. Understanding, right?
Yes.
Now, instead of length, if you write like this way, you can see now, I am taking D6 dot size. So that means D6 is the data, and in that data, there is a 100 data sets, a list of 100 data sets. I want to check how many rows and columns for each data in the list. So if I run this, are you seeing first one, 9.1, it has a 60 row, it has a 90 row, it has a 81 row, it has a 84 row, it has a 91 row. Corresponding to data size 9.1, I have 60 row. What did I run? I ran that one. Okay. So this is the line that will give you to find the number of rows corresponding to each data in the list D6. Okay. Here is the fun begin. Line 588 to 602. What they are going, try to understand. Now I have a list, that list hold 100 data, right? So I equal to 1 first data, I equal to 2 second data, I equal to 100 data. Okay, so if I put I equal to 1 first data, find the SS stands for statistics. Okay, import statistics as SS dot mean first data, find the mean of SBP. Then 2, find the mean of the second data. Understand? Then mean of the DBP, mean of the HT, mean of the weight, mean of the BMI. I equal to 1 first data, I equal to 2 second data, I equal to 3 third data, I equal to 100 data. How many means of SBP I will find? 100, right? Yeah, 100, right? 100 mean of SBP, 100 mean for the DBP, 100 mean for the height, 100 mean for the weight, 100 mean for the BMI. And this is the title. Okay? This is the title. This is the column title. This is the column title. And this is the value. Okay? So now take a look at DS equal to rows for underscore rows in D6. Okay, rows for underscore rows in D6. Length equal to length DS. Okay. Now that line is not important. 589. Import SS data list. I am making an empty list. So if this guy is hungry, suddenly he came to my door and then said that, oh, I'm hungry, I'm not eating anything. So I saw him, he's not eating for the last 3 days. So I will sit in my couch, okay? And then first of all, what I will give him? I will give him empty bowl, right? Empty bowl. Then I hold it. And then I give the cereal and then milk, right?
Yeah.
So data list line 591 is an empty bowl. Okay, it is empty bowl. I am filling it with the cereal and milk later. How? Are you saying data dot list? I am declaring in here line 593.
Yeah.
This is a empty bar. All of these calculations will be done and it will be put it in there in the append. Okay? And after doing all of these things, are you seeing these data list I am calling in here? And PD means panda concatenate. Concatenate is an English word that is meaning all of these things I am putting. Concatenate. Within parenthesis, you are putting some number, right? This is the number within this parenthesis. This concatenate means you are adding all of them together in the empty bowl. That means in the data list. You got the point, right? And then see, for I in range length of ds. ds equal to that, right? If ds equal to that, how many ways? So I equal to 1 if you will go there. So rows, remember, corresponding to 9.1, there is only one data, right? 9.2 only one data. So that length will declare like each data, how many? So previously I showed you in here, take a look at that. Length D6, right? 100. So take a look, how can I get all 100 informations at once? Are you seeing? After writing this, A is variable. Are you seeing A is title, right? This is. Then next one, mean.sbp. These are the title, 1, 2, 3, 4, 5. These are the title, and this is the computation. So computation of what? I equal to 1, first data. I equal to 2, second data. I equal to 3. So that means you are getting 100 rows. 100 means for 100 mean SBP corresponding to 100 ages. So how many lines altogether? Altogether maybe, let me count it from there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 12 or 13, 15 rows. So you are working with multiple data sets, okay? You might forget me, but please do not forget these lines of code. If someone will ask you, do you have any experience with working with the multiple data set at once? He said, yes, it is just the 11 lines of code. What? Could you give me permission to share my screen? Yes. So this is what? 11 lines of code. If you have a big data, like world population data, right? How many countries in the world? 200 countries. United Nations has like 194 or 196, something like that countries. United Nations has, right? So this is one big data. You enter there. You want to find the average number of children per family, longevity, average age of death, okay, GDP, per capita income, all of these things. Entire data, first split the data, okay, then run this line of code. Splitting data, that means when you split the data, it will become a list. That list will have a lot of data. D6 is the list. That D6 has how many? 100 data. Now I just run a loop. I got each and everything. Understand? That lines of code will give you a lot of things. So the 85 problems that I have been that I have put it in here. Let me tell you one thing. I was good in R, and then when my professor told me, could you develop a Python programming? One day he said. So I said, well, I have to take a look at that. Let me tell you a little history. It was in 2017, Christmas Day. So my daughter was just 2 years and 4 months old. So we wake up, we have breakfast as usual. Christmas Day, I went to the university and I was working in my office room, but nobody is in the university. Okay, in the parking lot, no cars, nothing. So I went there, but I cannot concentrate. I just don't want to. So and then I again came home after staying 2 hours. And then after coming home, I see more frustrating. My wife is sleeping with my daughters. Okay. What should I do? What should I do? So immediately comes, well, so I have the R code and data. Let's convert those things in the Python. So I first saw the YouTube video, and then I was just searching the online, all the 84 problems, 85 problems. So it take me 3-4 days to write all the course. Believe me, no buying any Python book, no nothing, anything, just from the 2017 I'm talking about. So now it is almost how many years? 7 years, right? Almost 7 years. Now a lot of materials develop. So if you have a desire and intention to learn, you can educate yourself. Okay. So the same thing, the things that I have computed, same thing I want to compute without using for loop. I don't want to use any for loop. I just want to compute everything without using for loop. So these things could be done by using this. So new is by mean, all the variables. This one line of code is so beautiful. D5 dot group by new is and mean. Okay. So this is the race mean, income mean, age mean, and waste mean, all of these things. If you go like this way. Okay. This is what the all mean. An alternative approach states by this. This is also exactly the same approach, but no for loop is used. D5 dot group by new age, and then I'm putting aggregating. This is the title, this is the mean. Title and mean, median, all of these things has been obtained in there. This is the aggregate SBP mean, DBP median, all of these things you are getting. Understand? And this is for the entire data. This is appropriate for overall measure. SBP, minimum, maximum, mean, and standard variance. If you find overall data, you will get this. Okay. Now the question number 73 is telling you, how can I do the double loop thing? Okay. How can I do the double loop thing? Question number 73 is telling you. So in order to do these things, line number 623 is telling me what? D5 is the data. From this D5 data, I take 10 rows and 10 columns. Okay. D5 is the data. From that data, I took 10 rows and 10 columns. After taking 10 rows and 10 columns, how does it look like? Let me show you. The D7 is the data. D7 is the data. That is the data looks like. I just want to show you, this is the 10 rows, 1 to up to like 0 to 10. So that means 11 rows, 0, 1 to 11, and 10 rows, 0, 1, 2, 3, 4, 5, 6, 7. So something is missing in there. So I want to take, this is 1, 1, right? This is 1, 2, 1, 3, right? So I equal to 1, j equal to 1, then this one. So take this one and subtract this grand mean, z. This grand mean, z means grand mean. Take the D7 data, find the mean. All the entries find the mean. I want to take I equal to 1 to 10 and j equal to 1 to 10. Or I equal to 1 to 11, j equal to 1 to 11. In that way, when 1, 1, that means first entry. Take the first entry, subtract the grand mean. So I equal to 1, j equal to 2. So that means first row and second column entry. In that way, I want to run the double loop. Okay. I want to run the double loop in here and want to compute these things. So this is the double loop that I wanted to run. And if I run this one, that is the answer. Let me explain these things. Let me go and explain these things in here. So see, D8, D7 dot to numpy. D7 data previously I have created that has been formulated in this format. After putting this for I in the range 10, for J in the range 10. So range 10 means here 0 to 10. So that means when I pick 0 to 10, that means I pick 11 rows and 11 columns, 0 to 10. So J equal to 1 to 10, J equal to 1 to 10. And then D8, which is this, I and J. When I take 1, J take 1 first entry. When I take 10, J take 1. So that means 10th row and first column. Okay. And then what I am doing, each entry subtract the G and take the square. So this is what I mentioned in there. Where is my document? Here is the document. Take a look. Select 10 rows and 10 columns from D5 data and denote it as a D7. Find the grand mean of D7 and denote the grand mean as a G. Subtract grand mean from each of the data points of the D7 by using double loop. These are the two things I have done. Understand? So what you have learned, how to do the double looping things. Now, without double loop, that is a very simple, naive thing. Just find the grand mean and subtract it from D7 data. And if you want to find the square of it, that is the way you can find the square of it. Okay. Question number 76, I need to write something. I need to write something in here. Let me see if I can. Long format data. What is long format data? Suppose this is ID. First person, first person, first person, second person, and then second person, right? So this is his A's. Suppose 9, 10, 11, 10, 11, 12, 13. What is the meaning of this? The guy appearing at age 9, first guy, again appearing first guy at age 10, again the first guy is appearing at age 11. On the other hand, second guy is first time is appearing at age 10, second time at his age 11, third time at his age 12, and fourth time at his 19. And during this time, we want to measure their height, weight, body, mass index, their blood pressure, and lot of other things, right? And this is called the long format data. This data is called the long format data, okay? So we need to transfer this as a wide format data. We need to transfer this as a wide format data, okay? So if you take ID, just 1 and 2. So ID, then you put here is 1, is 2, is 3, right? And then that guy, the ID 2, he has how many ages? Is 4, is 5. So first guy, this available, right? This is missing. This is missing. This is missing. Second guy, this available. Okay. So now you have to put this guy, first guy height, first one, height 1, height 2, and height 3. So this is available. So this data is called the wide format data. Understand? So for statistical analysis, they are in bioinformatics and biostatistics. Sometimes same persons, the different measurement in different ages need to be compared. This and that needs to be compared. If data is in the white format, then it is easier. Understand, right? So if you have a long format data, how can you transfer that long format data to white format data? If you have a white format data, how can you transfer that to the long format data? Clear, right? Sometimes that is needed. So just give me a second, I need to bring some order.
Why is it also selfish? That means that is the
Yeah.
So what I did in here, I picked the D1 data, and from the D1 data, I took the new ID variable and visit variable. So let me take the D1 data. From the D1 data, I take the ID variable and visit variable. Take the ID variable and visit variable. Take a look at the D1 data. D1 dot head. It is in this format. Are you saying the same person, right? Same person. How I say that this is the same person, but different time points. ID is same, but the age are different. Right? ID is same, but age is different. So in this case, I have taken ID and visit SBP, and then I want to visit like this way 0 equal to 1. So first visit was considered as a 0. So I want to recode it 0 should be 1. Okay, visit variable has a level 0, 2, 3, 4, 5, 6, 7, something like that. But 1 is not in there. I want to transfer visit 0 equal to 1. And then finally, if I write like this way, I'm getting this result. Now, are you seeing? This is only one ID, right? And this is his age. And this all the way it is coming in there. And then in this case, if within this one, are you seeing visit 0 and visit 10? So I took here visit, right? Visit. So that's the way. I think they have transferred that 1 equal to 0. Otherwise, why it is not as coming as that one? So let me check. Let me forget about that. So let me run this one and just want to run that one. And then write this one. It's still the same. So that code did not work then. So this is a 10-year follow-up visit. When the clinical trial data are collected, first visit they always consider as a baseline, base. Understand? And they, in order to easily identify that one, they name it as a 0. Okay. So that's the reason. But anyway, you have seen how this data is written, right? If you take a look at that one, let me see that one. So visit data. Plot history. Files. Views. So I want to take a look at the D1 data. Here is the D1 data. Yeah, D1 data. I want to take a look at the visit. I want to convince you. Are you seeing visit? There is no one value, there is zero value, right? Right? If you take a look at this one, visit one, see, there is no one value. These are all 0 to, so my purpose was to transfer this 0 to 1, but I don't know why that code was not transferring that things, but I will take care of that. So are you seeing there is maximum visit 10, right? And by row, you are now seeing close. By row, now you are seeing this 10 visits, right? So what you need to do, you want to compare base period with the final period. Base year data with the last year data. In order to do that analysis, you need to transfer the data from long format to wide format. So suppose all of us has a measurement for the first week of the class. What was our height, what was our weight, what was our blood pressure, and also last day of the class, we have taken height, weight, blood pressure, right? So there are 15 measurements altogether. Few students will have maybe 10 or 12 because they are missing classes for some reason. I want to compare first week with the 15th week. So in order to do that, you have to convert the long format data to wide format data. So now, how to convert wide format data to long format data? Suppose W1 on the line 663 is a wide format data. So I want to convert it to the long format data. So W1 dot copy stack level equal to 1, reset index level equal to 1, and sorted L1 columns. Finally, this is the data. You are getting back your original data. Now, if you ask me this stack, reset index, L1 columns, and sorted all of these things, those people who develop this Python, they come up with this word. Okay. So when I was learning the code, I was asking my professor, how do you know these things? How do you know this? The professor said that the more you will do, then you will learn gradually. Okay. Didn't I tell you if it is now 1980, I will have to come with the 2 or 3 books. And during the class time when the code is not running, I have to take a look at that. And you are asking, oh, could you check how to do that things? So that is why in 1980s and 90s, there are altogether maybe 4,000 to 5,000 programmers all over the world. 19s, the US universities during that time, like Stanford, Yale, Princeton, they specifically hire programmers so that PhD students get programming things from them. Physics, mathematics, other people, the PhD student, they go to the programmer. Programmer during that time has a heavy weight. Okay. During that time, there is no the people who did PhD during that they told us. But during that time, we have to walk to the programming center. That is a few programmers. We have to take an appointment to them. And they said, oh, what is this? Okay, they come. During that time, email was not in there. Either call or just go physically catch them. Understand? But now, nobody calls someone. Just do the Google things. It would be there. Now ChatGPT, my goodness. If you are expert in ChatGPT, you can do almost anything. That is the top universities now are thinking that they are going to the paper and pencil approach exam. So you have seen how to convert long format data to wide format data and wide format data to long format data, right? Now, question number 78, I don't want to spend too much time because this is the missing value technique. Nowadays, lot of data is generated with important missing informations. Important missing informations is what? Important values are missing. So there is a statistical procedure. They can predict the missing values by different approaches. Two very popular approach are predictive mean match. So I have a 1, 2 value, then the third one is missing, fourth and fifth one is there. So they are doing predictive mean match. And then there is a nearest neighborhood search. They compare their other values, their height, weight, and then their body mass index. And from there, they predict what would be his blood pressure. The algorithm. So question 78, I have written code how to impute missing value. If there is a missing values, how to impute those things. That has been discussed in question 78. If I discuss these things, it will take long time. I rather just want to run these things. But if you have a problem, you can ask me the questions, okay? So 79, 80, 81, 84, those are the data. Suppose you have a data in this format. You have a one data one. This is the data one. This is the data two. This is the ID variable, age and weight. This is the ID variable. This is height and blood pressure. Okay. So I want to match this ID variable between these two data and merge these two data so that final data will have ID, age, weight, height, and BP. Do you understand? This is called the what merge? Column merge. Column merging. Understand? So this ID and that ID will be matched, and this age and weight and this height and weight would be in there. That is column merging, and that is called the column merging, and there is called the row binding. Column binding or row binding. Row binding means ID variable, age, weight, height, body mass index. Okay, these data is suppose collected from Ohio. Okay, same ID, age, weight, height, and body mass index. Suppose that data is collected from Illinois. Okay, so these people and that people are different, right? One data is collected from Ohio, another data collected from Illinois. So I want to row merge. I want to put Ohio under this. So I will bring under there, and this is Illinois, and then I put here ID, age, weight, height, and body mass index. This is called the row binding. So I took these data. Yes. Yeah. You have to catch the bus, right? Okay. So that is the another data, N1 and N2. Now I want to merge them. Do you have a SQL experiences? Okay. So in SQL, there is a left join, right join, right? There is a left join, right join, something like that. And also there is a union intersection, something like that. Okay. So here they are using left on. That is the idea first came from the SQL in late 60s. So SQL developed was like around 65, 66, something like that. Okay. Structured query languages. This is what called the this is what called the column merging, and next one is called the row binding. This is called the row binding. And finally, appending rows. Okay, so these are the things you have learned, like how to merging data, how to subset data, how to row bind, how to column bind, how to run the single loop with the multiple data sets, how to do the visualizations, and how to draw graphs on grid with 3x3, 4x4, 5x5 by using the Python. Okay. So I'm going to stop in here. Few people might want to catch the bus at 8:25. So see you next week. If you have a question, you can email me.